An unavoidable part of being a programmer is that your programs are going to give a lot of errors. You can't avoid bugs. You can't avoid programs breaking. A simple print function here with, let's say, a misspelled word with, let's say, no comma. If I run this, we've been seeing this a lot, right? We've been seeing a lot of this red throughout this course. A lot of these errors. If I try to add 1 plus, let's say, true, click run, that works. But then all of a sudden I decide to add hello to 1. And yet again, we see that red, this time a type error. An error that crashes our program like this is called an exception. And Python raises these exceptions whenever the interpreter says, hey, I have no idea what you're doing. Something's wrong. I don't know what I'm doing anymore. I'm going to stop whatever I'm doing and I'm going to give you an output. This is bad because right now we're just playing. But if we're Google and people depend on us to maybe check their email, to watch YouTube videos, if our programs have exceptions and they stop working and they error out, that's bad. That could cost companies millions. So how can we handle these exceptions that crash our program? Well, we need something called error handling. It's a natural part of being a programmer. And a great programmer is able to handle errors in their program. Because instead of letting our programs just error, we're able to handle them so that if we get something like a type error like this, we can actually handle that error within our programs. And in this section, we're going to learn all about that. But the key takeaway is that error handling allows us to let the Python script continue running even if there are errors. Sounds pretty interesting, right? Well, before we get into that, let's just talk about some of the errors that exist in Python. We've already seen type error, where we're trying to do something between two different data types that are incompatible, such as adding int and string. And these built-in exceptions in Python, there's lots of them. And I'll link to this resource so you can take a look. But if I scroll through here, you see attribute error, end of file error. We keep going. We have a name error. We have so many errors, reference errors, just a ton. Let me just go through some of them that are quite common. One is a syntax error. If I do def and let's say who, and I forget a semicolon here, and I run this, I get a syntax error. It's not a standard Python syntax. I have to fix my error. I can also get something called a name error. If, let's say, I use 1 plus name, like this, and I click name like this, you can see the red underline here. I get undefined name. So that if I run this code, I'll get a name error. Name is not defined. We've seen type error. But what about this? What if we have a list, let's say li, 1, 2, 3, and I access li, let's say, at index of 5. If I run this, I get an index error. List index is out of range. What if we had a dictionary? So let's say we're creating a dictionary here. We'll say A equals 1, and I will just leave it at that. So this will be a dictionary. If I do dictionary here and just try to access something that doesn't exist and I click run, I get a key error because I'm accessing a key that doesn't exist. We can also have, let's say, 5 divided by 0, which should give me a 0 division error because I'm trying to divide by 0 and, well, you just can't do that. So there's lots of errors or built-in exceptions in Python. Now, you don't have to memorize any of these. Most of the time, they'll come up in your program and you'll know what they mean. But you can always use this as a reference to read them. But the question you should be asking yourself is, how do we avoid these? Because most programs aren't just us typing information. Usually programs interact with the outside world, right? When I log into my email, I let a user use their email and password. When I play a game, I let a user control a character. So programs are constantly interacting with the outside world, and they have to make sure that whatever input they get is the right type that they're expecting. Because if they receive something that they didn't expect, like number, and this number just happens to be, let's say, 0 that we give it, well, this user broke our program. So we need to handle these situations where a user might give something bad that we wouldn't want. In the next video, we're going to explore how we can handle our errors. I'll see you in that one. Bye-bye. Error handling allows us to let the script continue running even if there is an error. Let's try an example to show you how we can do error handling in Python. Let's say we wanted to create a program that allows us to take a user's input. Let's say that we ask the user for an age. So we use the input prompt and say, what is your age? And then here, all we're going to do is just print the age. Nice and simple program. If I run this and I type in, let's say 10, there you go. Everything is working. But what if I didn't enter a number and I go like this? Well, that still works, but is that what I wanted to do with my program? Maybe I wanted to enter the age and calculate if they can play the game or not, whether they're 18 and over. How can we fix this? Well, one thing we can do is just to wrap this in an int, right? So we convert whatever the user gives us into an integer. So that if I run this and I type this, I get an error, a value error. Invalid literal for int. I'm trying to convert this into an integer, but it's telling me that's an error. I can't do that. So how can we fix this? With error handling. In Python, we can do it this way. We have the try keyword, which says, hey, I want you to try this piece of code. And we have to make sure we indent it. So we try this piece of code. Now, anything that happens inside of the try block, I'm able to handle, see where handling is coming from errors, with the except keyword. And except says, hey, if whatever's in here in the try block, if anything errors out, I want you to say something. So instead of having this red error that exits out of the program, do something else. Do this. So I'm going to say, print, please enter a number. Let's see what happens now. If I click run, what is my age? I'm going to just write gibberish. And look at that. I get, please enter a number. I am handling my errors here by wrapping all of my code in a try block. So I could have just copy pasted my entire file here, put it inside of a try block. And what's going to happen is instead of my program erroring out before my program crashes, it's going to run this code and then it's going to say, hey, if within this block anything happens, we'll catch it in here with the except block. And I can here do whatever I want. In my case, I can say, hey, please enter a number. But we have a problem here, right? The program just ended and we want this to keep running. I have to click run again and ask for the age once again. So how can we make sure that we keep running this until, well, the user actually enters something valid? Well, we've seen this before. We can do a while loop and say while true, run this, and if this works, well, we're gonna hopefully get the age. Let's see that. If I click run, what's my age? Let's say, nope, please enter a number. What's your age? Let's try to break it again. Nope, please enter a number. All right, fine. My age is 10. There you go. I get the name 10, but it's still asking me what's my age. Ideally, I want to break out of this true statement, right? So how can I do that? Well, I can use what we call in here an else block, which we've seen before. But this works with a try except block. We put it at the end. It says, hey, try this. If there's an error, do this. However, if there is no error, else do this. So in our case, we can just say break. And you know what? We can even print thank you, just so we're nice. If I stop this and run again, and I give them my age, there you go. We're done. We broke out of the loop, and everything is good. And this try except else block can go anywhere. We can wrap our entire file in a try except else block. We can just add it into our functions inside of our each individual functions. Whatever we want, we can use. This is just another tool that Python gives us to handle errors. But let me ask you something. What if I did, instead of print age, I did, let's say, 10 divided by the age? If I run my program and I type in here 0 and I enter, I get an error. Please enter a number. But I did enter a number. This is a buggy program. Although I'm typing a number, it's still giving me the same error message. So how do we handle this? How do we handle different errors? One where it is a value error, and another one that is obviously a zero division error. Well, in the except block, I can simply give it what type of error I want to handle. And remember, these are built-in errors in here that I can just copy and paste. So in my case, I want to say this is for a value error. So that if I run my program and I type in 0, I get my error. This except block only accepts value errors. Any other errors, it does not care about. So what can we do here? Well, one option is to copy here and say, hey, let's add another except. And in this case, I want a zero division error. In case a user enters 0, you can say, please enter age higher than 0. So that if I run this now, and I do 0, I get, please enter age higher than 0. If I do some gibberish, I get, please enter a number. If I finally enter a number, look at that. Thank you. Everything is working. Now here's my question. What happens if we enter another value error here? And this value error is just going to say exclamation marks. What happens now? I get, please enter a number. Because this except block is going to run only once. As soon as it catches the error it's looking for, it's going to run and then come back to the while loop. So only one of the errors will be caught. Okay, let's take a break and learn more about error handling in the next video. Bye-bye. Let's try a different example here. Let's say I'm creating a simple sum function. Yes, I know it already exists in Python, but we'll just create our own. A simple one that takes num1 and num2, And in here, we'll just return num1 plus num2. Now, if we were to just simply do sum1 and sum2, and I ran our program, well, let's print it out first. I click run. I get 1 and 2 because it just adds the two strings together. So let's just do this and click run. I get a type error. Must be string, not int. So based on what we learned, how do we handle this? Well, we can add a try block in here and wrap this function, or we can build it directly into our function. So I can say try this part, and here have an except clause that says perhaps if we get any type of error, we'll print something is wrong. If I run this, I get something is wrong. But here's the problem. By just doing except with no exceptions, as a programmer, I'm reading this and I don't really know what actually went wrong because it could be so many things. So a good practice is to always catch these errors based on a specific exception. This way, you know what the error is and you can be more descriptive. So here we can say type error, and this type error, we can just say, please enter numbers. So that if I run this, I get please enter numbers. So now, all right, my error is more descriptive. I should fix this and make sure that I enter numbers. Awesome. Now, a common pattern when doing error handling is to do something like this. Type error as, and then doing something like a variable. So whatever variable we want. In our case, let's just say error. So I'm saying, hey, if you catch type error, let us use error in our error message. So I can say here plus error. So that if I run, and let's do a string here. If I run, look at that. I get the error printed. Let me just open this up a little bit so you can see it clearer. Look at that. It actually gives me the error that I want. So that I can see that on line 5, on this line, I get a type error, unsupported operand. And I get a descriptive error of what is happening. So maybe I could use it in my output message. But what if I don't want to use this and I do run? All right, everything is working. Again, if I do plus error and I click run, and this is actually tricky, but it says here, during handling of the above exception, which I'm doing, another exception occurred. Oh boy, I tried to handle something and I had an error within that error. So this is sometimes tricky, but what it means is what we get out here is actually an error object. It's a built-in exception in Python. You can't add in here the way I have. Instead, we want to use an f string. So I do f, and then here pass it the error. So that now, if I run this, I get please enter number, unsupported operand, type S for plus, int, and str. So I actually get this error available to me. Now, if I was to just print this error, let's see what it looks like. If I click run, you see this is the part of the error that we get. So it's very, very useful if you want to give meaningful errors to your users. Another interesting thing you can do is something like this, where you wrap these errors together. So let's say we have 0 division error as well. And here we'll just say, oops. If we, for example, divide num1 by num2, let's just run this first. I get oops. If I do 1 divided by 0 and I run this, I also get Oops. So I can handle multiple errors the same way. I can also say as error here and just actually print out the error. And if I run this, I'll get division by 0. Or if I do a string and run this, I get the other error type. So this, again, is really useful to combine different errors if you want to handle them the same way. But what if we actually want to raise our own errors? That is, we want to throw our own errors. Maybe inside of this except block, I actually want the error to display for certain types of errors. How could we do that? Let's find out in the next video. Let's go back to our example of our game, where we have a user log in and they have to provide their age. Remember, if I click run, it's going to ask me, hey, what's your age? And if I give it something that it doesn't like, it's going to keep asking me until I provide a proper value. There's one other piece to the try except block that we haven't covered. So we know that we have try, we have except, and then we have else. But there's also another thing called finally. And finally runs at the end after everything has been executed. Let me show you. If I do print, let's say, okay, I'm finally done. Let's see what happens. If I click run here and I give it a proper age, I get thank you because my try block succeeded. Nothing has failed. I go to the else and I say thank you. And now I break out of the while loop. But finally says, hey, no matter what, at the end of it all, I want you to finally do something. Let's see this in action if I do something like 0. I get, please enter age higher than 0. But then also still get, okay, I'm finally done. What if I enter gibberish? I get, hey, please enter a number. But also, okay, I'm finally done. So finally runs regardless at the end of everything. Why is this useful? Maybe you're working on a game server and you want to make sure that you log out any activity on the server. So let's say a user tries to log in, even if they try to enter the wrong information. We want to log that activity so that maybe we can detect that there's people trying to break our program, or just to have our records that, hey, this user has tried to log in 10 times. So finally is very useful. Now, let me ask you a question. What happens if I do something like this? Let's say I have here continue and maybe another break statement here. And then maybe inside of here, I'm also going to have a print. Can you hear me? What happens if I do something like this? Pause the video if you need to. Otherwise, I'm going to hit run and see what's going to happen. What is going to happen if I enter 0? Ready? I get, please enter age higher than 0. Because I get a 0 division error, it catches here, and then we break out of the loop. The finally gets run, but print never runs because, well, we break out of the loop, and remember, this is surrounded by the loop. Let me remove this so we can see it better. Okay, what happens if I do something like this? What if we run the program again, and this time give it gibberish? Let's find out. I get, please enter a number. Okay, I'm finally done. And then what's your age? So what happened here? Well, we tried this. We got an error, a value error. It says, hey, please enter a number. And then it's going to continue. Now continue, instead of break, doesn't break out of the loop, out of the while loop. Instead, it comes back to the top. So it's going to try again this part. What's your age? Okay, so what if we finally try to log in properly and give it, hey, we're 18. What happens next? There you go. I get, thank you because we've tried it, everything works, so no exception. So we're going to get thank you. And then we break out of the loop. So once again, this print never gets printed. Can you hear me? But then finally, okay, finally is done. If we didn't have this break statement here, and I click run and give it 18, oh boy, finally, I can hear you. This print finally gets printed because we don't break out of here, we don't break out of here, and then we run this line. Hopefully that makes sense. That was a bit of a trick question, but you're starting to get the hang of it. I'll see you in the next video. Bye-bye. So we've just created a program that isn't going to error out. Hopefully, at least with value errors and zero division errors. But sometimes errors and exceptions can be so severe that we do want to stop our programs from running. We do want to catch them like this with the except block, but at the same time, also stop whatever the program is doing. Maybe instead of print, we actually want to display that red here and says, oh, something bad's happening, stop that. Well, in that case, we either don't use the except block, or in here, we can say raise value error. Now, this is rare that you'd have to do this. There are some specific use cases, but here you would just write a message saying, hey, cut it out. So that if I run this, well, if I type in a valid number, I get, please enter a number. Okay, I'm finally done. Because I raise a value error and it throws in here into the except block. So I'd have to remove this. And if I remove this like this and hit run, enter 5, and look at that. I get a value error. Hey, cut it out. So I'm able to throw my own errors. So this is really useful if you're creating your own library or tool and you want to let the user know that an error happened. I'm not going to keep doing what you're doing. And this could be any type of error. You can also do something like exception. And if I click run here, do 5, I get an exception. Hey, cut it out. The key thing to remember with errors is that errors are unavoidable in programming. What your job is as a programmer is to be able to anticipate these errors, these bugs, these exceptions, and handle them properly in your programs. And some of the biggest errors happen when we're trying to accept input from a user, not just using this input, but functions accepting arguments, classes accepting different inputs from users like method calls, and trying to change attributes. When the outside world in our programs try to communicate with each other, errors are bound to happen. Our job as programmers is to try and code in a way that handles these exceptions gracefully, and we can anticipate these errors. There's no such thing as a perfect program. However, we can try and do our best to learn from these errors and try to manage them so that our programs don't break. I'll see you in the next one.